different geometric shapes. Well, repeating geometric shapes in this coil. It's a bifather coil. One of the circuits goes this way. The other circuit crosses over it in a specific angle. Okay, and I have several, and that does that several times here in the center. And it's a specific geometric pattern that I've created, and it goes along with the way I'm going to pulse the coil. It's a very specific way I'm going to pulse the coil or energize the coil, and it pertains to the mathematical geometry of the coil that I just finished putting together here, that I'm experimenting with today. What we got here to the right is an amp meter, and it's right now, as you can see, it's reading 0, so there is no energy going through the coil right now. There are my 4 leads coming off of my amplifier, my left and right, positive and negative. Okay, and the amplifier is then hooked up to my laptop, and the laptop is what I'm going to be using the pulse the coil with. It has the frequency and the very specific way that I'm going to pulse this coil that I've developed in the laptop. So and then this meter here, so I'm going to use to show you what the amplification of energy is around the poloidal diameter of this coil, which is this way. All right, so let's get started. Let me get this energized. Okay, so now we're drawing roughly 1.5 amps coming into the coil. Now let's see what we've got around the diameter. Looking at 212 amps. Okay, as you can see, let me show you the settings I got here. As you can see, I've got it set at 600 amps. It's a Fluke 32 meter, very good, high quality meter. Set at 600 amps. All right, we're reading about 212. Okay, so that's roughly what 116 or so times energy amplification. So we got 1.6 amps going in, and 210, 212 in the center of the coil. It's a very significant energy amplification. One of the other things I wanted to show you, let me get this out of the way. What I have here is a 1-inch neodymium sphere magnet. It's a grade N42, and when I stick it in the middle of the coil, it starts to spin, but not only spins, but it actually, the magnetic field holds it very tightly to the center of the coil. Okay, I can wobble it around a little bit, but it's essentially levitating in the center of the coil very powerfully. I can turn this thing around and it won't fall out.